Hello dear students, let us study the remaining topics of the lesson light in today's class. Then the first topic is how to draw the ray diagrams for image found by a concave mirror. Then let us consider here. First you need to understand where should the object be placed before drawing the ray diagrams for image formation. Then first position of the object will be object is considered to be at infinity. Then when the object is at infinity, let us consider at infinity. Then what will be the nature, size and position of the image? Let us take here first one. You need to consider a concave mirror. You show one side rough surface. You draw a principal axis. This is pole of the mirror. This is principal focus. This will be the center of curvature, right? Now the object has to be considered at infinity. Then you have to take two rays parallel to the principal axis, one above, one below. This is the object. Now a ray which is parallel to the principal axis, after reflection it passes through a point on the principal axis called principal focus, as you have already studied in the previous class. Now at this point where these two rays are meeting each other, that is principal focus. At principal focus we find the image. You need to show the direction of reflected ray, and a ray of light passing through the principal axis, it follows the same path. Now what do we say? Image is formed at the focus. It is highly diminished. Next it is real. It is coming out of the mirror, so it is real. It will be looking upside down, so it is inverted. This is nature, size and position of the image when the object is at infinity. Then let us consider the next point, that is when the object is beyond C. When it is beyond C, what will be the nature, size and position of the image? Again you need to show here a concave mirror. One side rough surface. Draw a principal axis. This is pole of the mirror. Principal focus, center of curvature. This center of curvature, this C has to be to the distance which is double the length of focal length, that is principal focus. Here we are taking C. Now when the object is beyond C, you have to consider one ray which is parallel to the principal axis. Now another ray you need to consider which is passing through the center of curvature. Center of curvature. A ray which is passing parallel to the principal axis, after reflection it should pass through the principal focus, as we have already studied. Right? Next, a ray which is passing through this center of curvature, it passes the same path, means it follows the same path after reflection. Here where these two rays are meeting each other, that is intersecting each other, at this position we are getting the image. That is, if it is AB, you can show it as AB here. Here B is up, here B is down, that is upside down, that is inverted image you are getting. Okay, you have to show this direction of propagation of light after reflection and before reflection. And a ray of light which is passing along this principal axis, it follows the same path after reflection. This is when the object is beyond C, the image is between C and F. It is between C and F. It is diminished as compared to the original size of the object. The image size is diminished, right? Next, it is real and inverted. It is looking upside down, so it is real and inverted, we can say. This is nature, size and position of the image when the object is beyond C. Then next point we need to consider when the object is at C. At C, what will be the nature, size and position of the image when the object is at C? Now, this is a concave mirror. You need to show there is a mirror as just Mn you can consider. Here this is pole of the mirror. You consider here principal focus. This is center of curvature, that is C. Now when the object is at C, where will the image be formed? Then what will be the nature, size and position that we are going to, that only we are studying there here. First, you need to consider a ray which is parallel to the principal axis. Another ray you need to consider which is passing through the focus. Now after reflection, this ray, it passes through the principal focus according to the rules as we have already studied in the previous class, right? And this ray which is passing through the principal focus, after reflection it should emerge parallel to the principal axis. If it emerges parallel to the principal axis, you can just observe where we are getting this image. Image is exactly formed at the C. And if you consider the size of the object and size of the image, both are same. A dash, B dash you can show, right? Now you see what is the size? Same size. Where it is formed image is formed at C. Object when it is at C, image is also formed at C. Okay, questions will be arising based on these types of ray diagrams. When the object is at C, where will the image be formed in a concave mirror? That is at C. It is formed at C. You need to show the propagation of light. A ray which is passing along this principal axis, it follows the same path. Here you need to show these arrow marks properly. Okay, this is when the object is at C. Then what are the nature, size and position? Nature of the image is, it is real and inverted because it is coming out of the mirror. Okay, it is coming out of the mirror, it is looking upside down, so it is inverted. Where it is formed? At C it is formed. What is the size? Size is the same as that of the object. Image size and object size both are same when the object is kept at C. Questions can be formed in any form here, so you have to be careful with that. Next, when the object is at C over, let us bring the object close to the mirror. That is next point you can consider between C and F. When the object is between C and F, what will be the nature, size and position of the image? Again, you need to consider principal axis, right? This is pole of the mirror, Mn mirror. Now you have to consider this is principal focus, this will be center of curvature, right? Now when the object is between C and F, you have to take one ray which is parallel to the principal axis, the other ray which is passing through the principal focus. You have to consider because these are the closest points where we can consider a ray of light to be moving. Now you have to take, this is propagation of light, that is A and B we are showing. Now this ray which is parallel to the principal axis, after reflection it should pass through the principal focus according to the laws. See, next, now a ray which is passing through principal focus, it should emerge parallel to the principal axis after reflection, as you know already, right? So where these two rays are meeting each other, at this position we get the image. Now you can see this is A dash, B dash, you can show. Now image is beyond C now. What is the position? When the object is between C and F, image is formed beyond C, right? What is the nature? It is real and inverted, and it is enlarged. As compared to size of the object, image is bigger here. So we can say image is enlarged. Okay. So you need to consider these rays. This is incident ray, this is reflected ray. Right? You should remember these also to mark there properly. Okay. Rays of light which is moving along this principal axis, it follows the same path. Next, this is when the object is between C and F, what will be the nature, size and position of the image? This is over, that is beyond C, enlarged, real and inverted. Next, this we did not show, between C and F it is, when the object is between C and F. Next, let us consider when the object is at F. We have to consider this time when the object is at F, what will be the nature, size and position of the image? Let us take this concave mirror, principal axis, this is pole of the mirror, this, let this be principal focus, this is center of curvature, principal focus, center of curvature. Now when the object is at the focus, that is at F, now you need to consider one ray which is parallel to the principal axis, another ray which is passing through the center of curvature. One ray you can consider with respect to the center of curvature. A ray which is passing through the center of curvature, after reflection, it follows the same path. A ray which is passing through, passing just parallel to the principal axis, it should pass through the principal focus after reflection, right? So what happens here, you can consider these rays. How do they appear? They appear parallel to each other. They do not appear to be meeting at any point. They appear to be parallel to each other. Let us take this exactly up to the mark. If you take, see, they appear to be parallel. See, means image is where it is formed at infinity. When the object is at F, image is formed at infinity. When the object is at infinity, image is formed at F. Okay, if you learn, the other will be very much easy to understand. Now, image is formed at infinity. What is the size of the image? Image is highly enlarged. Because it is formed at infinity, highly enlarged it is. Since it is coming out of the mirror, it is again real and inverted. Real and inverted image we are getting. It is formed at infinity, and real and inverted formed at infinity, highly enlarged. Okay, when the object is at F. When the object is at F. Next, last point we have to consider when the object is between P and F. This is the mirror. Consider a principal axis here. This is principal axis. This is pole of the mirror, mirror MN. When the object is, this is F. Okay. When this is between P and F, we will show. Okay. When the object is between P and F, now this will be the center of curvature, right? Now when the object is between P and F, what happens? See, you need to consider here, there is no any other points to consider. So one ray we can take it as oblique one here. One ray you can consider obliquely moving. Another ray you have to consider which is appearing to be passing through the center of curvature, right? One which is appearing to be passing through the center of curvature, it follows the same path after reflection, right? And this is oblique one. After reflection, it moves obliquely. It emerges obliquely, making the same angle, following the laws of reflection. That is, angle of incidence will be equal to angle of reflection, right? Now, if you extend these rays backwards, straight you have to extend, and this also you extend. Here these two rays are meeting each other. At this position, we get the image. How does the image appear here? If you consider this is AB image, here also it is A dash B dash. It is erect, it is. This time the image is erect. Okay. It is formed behind the mirror. We cannot get it out of that mirror there. So it is virtual. Since we can see the image behind the mirror, it is virtual image. It is erect image. Where is the position? Behind the mirror. Position of the image. What is the size? Size is enlarged as compared to the object. Image is enlarged. So this is nature, size and position of the image when the object is placed between P and F. See, this is P, this is F. In between when it is kept, this will be the nature, size and position of the image, right? Now, questions can be asked based on this. How, when the object is placed between P and F, where does the image appear? Yes, it appears behind the mirror, right? Otherwise, what is the position at which we get the erect image in case of concave mirror? What will be the position? It should be between P and F, right? When we come to know the uses of these concave mirrors, based on that also question can be asked. Why is concave mirror used as a shaving mirror? That we are going to learn under uses. There I'll say that one. Okay. So these are different positions of the object when it is placed there, the nature, size and position of the image that we have already studied now. Now let us study what are the uses of concave mirrors then. Concave mirrors, they are used in headlights of the vehicles and they are used in searchlights. In headlights of the vehicles, they give a powerful beam of light. For that purpose we are using. And in searchlights also, you might have seen in some of the movies, they will be showing there to find just premises of that uh, prisons or jails, that will be just covered with one searchlight. A powerful beam of light will be just moving around that area premises, that is called searchlight, because that will also focus the light in one direction. Means powerful beam of light it gives there. There it is used. Next, these concave mirrors are used by dentists to see the enlarged image of the tooth. Just when they place that concave mirror behind the tooth, the image of the tooth appears erect and enlarged. Next, these are also used as shaving mirrors. Concave mirrors, they are used as shaving mirrors because erect and enlarged image of the face can be seen. And not only this, these can also be used in industries to concentrate sunlight to produce heat in uh, furnaces. Okay, in furnaces of the industries, they will be using these. Okay, so these are uses of concave mirrors. It is very much simple. Concave mirrors users you can very easily you can write. Then what question can be asked based on this? Question can be asked like this: to get the large enlarged image of the face of a person, where will the face should be placed in front of the concave mirror? That is between P and F. At that position only that person will be made to sit. Because of that, it will be appearing enlarged and erect image we get in case of a concave mirror. Only except this position, all other positions they are giving us real and real and inverted images it is giving. Only it is the position between P and F. Only in that case we are getting enlarged and erect image we are getting, and that is found behind the mirror. Right? Virtual it is. Virtual we are getting only in case of when the object is placed between P and F. Remember. Next, we need to consider what will be the image formation by convex mirrors. In case of convex mirrors, we need to consider only two positions. When the object is at infinity, next at finite distance. Finite distance means when the object is between infinity and pole of the mirror. Only two cases we need to consider. In those cases, we are going to learn. See, now let us consider when the object is at infinity. How will the image be formed by a convex mirror? Now, at infinity. Now, convex mirrors image formation we are considering. Convex mirror, as you know already, here rough surface is inside and its outward surface is polished one. You need to show a principal axis. Let us call this as EMN mirror. This is pole of the mirror. Now, this will be principal axis. Now you need to consider an object. When the object is at infinity, you have to consider one ray which is parallel to the principal axis. The other will also be parallel to the principal axis, because when the object is at infinity, the rays coming from that object are considered to be parallel to the principal axis. Now, a ray of light which is passing along the principal axis, it returns in the same path. Now, one which is parallel to the principal axis, after reflection, it diverges, right? This ray of light diverges. Here also it diverges. Now, this divergence, it appears like this. Means these rays, they are appearing to be diverging from a point on the principal axis. This point is called a principal focus. Right? Now, the image is appearing to be formed at the focus. When the object is at infinity, the image is formed at the focus in case of convex mirror. How it is? It is highly diminished. It is highly diminished image when the object is at infinity. And what is the nature? It is virtual and erect. In case of convex mirror, the image formed is virtual and erect. It is formed at infinity, right? uh, it is formed at focus. When the object is at infinity, the image is formed at the focus. This is when the object is at infinity. Next case we have to consider when the object is between infinity and pole of the mirror. Again you have to consider the principal axis, right? This is pole of the mirror. When the object is at a finite distance or between infinity, when it is between infinity and pole of the mirror, how do you consider? You have to consider a ray, one ray which is parallel to the principal axis. This ray which is parallel to the principal axis, it appears to be diverging from a point on the principal axis, that is principal focus, as we know already. Behind the mirror you have to extend the line with the dotted lines, right? Now you have to consider one more ray of light which is appearing to be passing through the center of curvature. From here you need to consider. This is center of curvature. Here if it is appearing to be passing through this, and after reflection it follows the same path. You know that according to that rules what we have studied in the previous class. Now the position where these two rays intersect each other, here with the dotted lines we need to show, I said, okay, the position where these two rays they are intersecting each other, at this position we get the image. Now the image is virtual and erect. If this is A, B, this is A dash, B dash, right? Where is the image formed? Image is formed behind the mirror, that is between P and this will be F. Okay. Between P and F, image is formed between P and F. This is position, that is pole of the mirror. This is principal focus. Between these two points P and F, between P and F, image is formed when the object is between infinity and pole of the mirror, right? What is the nature? It is virtual and erect. Virtual and erect. What is the size of the image? Image is diminished as compared to the object. Object is bigger in size, image is smaller in size. It is diminished, we can say. So this is image formation by convex mirror. Only two positions we are considering. One is when the object is at infinity, and the next is when the object is between infinity and pole of the mirror, that we are considering. That we have already finished now. Next question arises, where do we use these concave mirrors, convex mirrors then? Convex mirrors are used in automobiles for rear view. They will be asking you many times, what is the reason for using the convex mirror as rear view mirror on automobiles? The reason is like this, as the uh, convex mirrors surfaces are curved outwards, since it is curved outwards, it covers a larger area, means large field of view it covers. And though even it is diminished, means though even it is small in size, image is erect. That is one more point. It covers large area and it is giving erect image. For this purpose, we are using these convex mirrors on automobiles for rear view uh, as rear view mirrors we are using. So this is the reason for using those, right? Next, coming to new Cartesian sign convention for spherical mirrors that we need to consider. Now we need to consider new Cartesian signs. What are these Cartesian signs? Very much simple, as you know already about a graph, you are familiar. In the same way, if you consider, let us take this as a concave mirror. If you consider like that, here we have to show this principal axis, as you know already. This is principal axis. Now we are considering, according to this new Cartesian sign convention, we are considering this principal axis as x-axis, x dash. How we are considering like that, and this is pole of the mirror. This is considered as the origin. If you consider this as like graph, if you consider this point will be origin. Okay, it's not coming straight. Okay, this is origin. P, pole of the mirror, it is considered as origin. Now this principal axis, it is considered as x-axis. Now that always we should consider the object is always kept on the left side of the mirror. Always we are keeping the object on the left side of the mirror, we need to consider. This means what? It means that the light from the object is falling on the mirror from left hand side. Like this, light is falling on the mirror. It is showing. It may be concave or convex. Always we should place the object on the left side of the mirror. Next, you have to consider this pole as origin of the mirror. If it is origin of the mirror, now the distances which are measured parallel to the principal axis, the distances measured parallel to the principal axis and towards the left of this pole of the mirror, they are considered as negative values. Means, as you know that already, from the origin negative numbers will be there on the x-axis, right? On the right side of that origin there will be positive x-axis, that is positive values of x-axis we will get. Next, if you consider the distances measured parallel to the principal axis and to the right of the origin, they are taken as positive values, and to the left they are taken as negative values, the distances measured. Okay, these distances are always measured from the pole of the mirror, because pole is considered as origin. Okay, it is considered as origin here. From this only the distances are measured there. Okay, how they are measured? Parallel to the principal axis, if they are measured to the left, they are taken as negative. If they are measured to the right, they are taken as positive values. As we are considering graph, exactly same. Next, if you take this as y-axis, vertical line which is passing through this, means which is perpendicular to this principal axis, that we are considering this as what? Y-axis. Y, this is y dash. As you know that already, if you take the height of the object here, how we are measuring? From the origin along the y-axis, and this gives what? Positive values. Now the distances which are measured perpendicular to and above the principal axis, they are taken as positive, because positive y-axis. And the distances which are measured perpendicular to and below the principal axis, they are taken as negative. Okay, they are taken as negative. and this is origin, as you know that already, right? This much you need to remember. Then we are going to learn what is mirror formula and magnification, because these are going to come while calculating the sums based on these spherical mirrors, maybe convex or concave, whatever. There we are measuring, there means we are using these sign conventions. Now coming to mirror formula and magnification. What is mirror formula? It is 1 by V plus 1 by U is equal to 1 by F. This formula is called what? Mirror formula. Here U is object distance, V is image distance, F is focal length of the mirror. That is convex or concave, what they are giving there, that is focal length of the mirror, right? Now magnification, one more term comes. What is that magnification? Magnification, that is magnification is nothing but, that is m is equal to magnification, that is h dash by h. What does this mean, h dash by h? H dash means it is height of the image. This is height of the image, height of the image, and this is height of the object. Means what? Here magnification is nothing but it is the relative height of the image with respect to the object. That is what we call it as magnification, right? And this magnification we can write it like this also. M is equal to h dash by h. This can also be written as minus phi by u, because this depends on this magnification depends on the distance of image and distance of the object also, with a negative sign. So these are just a formula, let us remember, and in the next class we can go ahead with the calculations which are given, that is applications of this mirror formula and magnification. In the next class we shall study that one. Okay, right? Okay, thank you.